So while you guys are sitting down, let me briefly introduce myself. My name's Lam. I go by Mila, and I work as Go engineer here in STRV. Yeah. So my topic is observability and monitoring Go services in AWS. So firstly, just a temperature check. How many of you guys are familiar with AWS? Okay, a lot. What about Go? Okay, so that's great. So just very briefly, what is observability? It's an ability to understand what's happening in your system. In our case, it's a backend app by examining its outputs, specifically telemetry, which is mainly logs, tracing, and logging records. Why we need observability? So in production systems are very complex. It's very hard to try to debug just by going through the code without seeing any data, and failures indeed do happen. We are all familiar with that. What it can help with: faster incident response, proactive issue detection, and better performance optimization. So there are 3 pillars of observability, as I mentioned. First one is logs, the most simple one, basically timestamp records of discrete events, helps you understand what happened and when. Yeah, as an example from CloudWatch, this one is structured, so the log format is in JSON, which helps you with querying the logs and basically just navigating in them. Second one is metrics and alarms. So metrics are numerical measurements over time. It helps you understand system performance and trends. And alarms can be built on top of metrics, and they can send notifications based on certain values in metrics. You can set a threshold, for example, if the CPU usage is over 80%, it should send you, for example, an email that something bad is happening to your service. And the last one is traces. There are records of requests or operations flowing through systems. They can be distributed, so across multiple components in, for example, AWS, or also they can be operations executed within a single request, as we can see on the example. I think it's too small, but the traces, they describe execution of a request. You can see how long certain database queries take, when they are executed, and so on. But we will look into that later on. So yeah, let's get to implementation. I've created a project for this talk. The project is this one. It's a Go service that manages coffee orders. I've employed my dear colleagues as baristas, some of them. So the service exposes the following endpoints. We have health, that's mainly for, as any backend service should have. It's mainly for AWS infrastructure stuff. Then we have get coffee, and then we have multiple 6 make coffee endpoints, basically from each of us, from the Go team in STRV. Every single one of us has a different style of making it, so we'll go through it very soon. So core technologies, the whole service is written in Go. We use Gochi for HTTP routing. That's a library used a lot for routing. Then we have a PGX Postgres driver. We use Amazon RDS database, which is basically built on Postgres, and it's all deployed on AWS. Very simple diagram of the infrastructure. So I want it to be as simple as possible. So there's a public load balancer that points to ECS cluster where we have two task definitions. One is our actual service, and the other one is AWS Open Telemetry Collector. I'll talk about that later on. And technologies that are used for the observability. We're using AWS CloudWatch, which is a platform, a part of AWS platform. And that's where you basically store and track all of the telemetry data from your app or other places in the AWS structure. Also, we use Zap Logger, which is a library for structured logging. We use Open Telemetry for tracing. You can use Open Telemetry for logs and metric as well, but I've decided to use it only on tracing since the topic is on AWS. Why Open Telemetry? Why not using AWS SDK directly for traces? That's because AWS decided to deprecate the SDK for tracing, and they urge us and recommend to migrate to OpenTelemetry and use the OpenTelemetry AWS collector to sync and be compatible with CloudWatch and CloudWatch X-Ray. But we do use AWS SDK for sending metrics. Yeah. So what have I instrumented my project with? So I'm using structured logs, using the Zap logger library. I've created custom dashboard for predefined and custom metrics. The predefined ones are classic ones, so CPU and memory usage and the request count and request duration. That's coming from metrics sent by load balancer. And as for my custom metrics, I am using a coffee order count. So how many coffee orders have the service processed and created. And also I've also created the by type version so that we can look, basically look at the values based on which coffee type was being prepared. I've created also 2 alerts on these metrics. So no more than 5 coffee orders in 10 minutes can be created. Otherwise, we will get an alert. And also response time cannot be higher than 2 seconds. And lastly, I've instrumented the app with X-ray tracing, as we will see. Because I would like to show you a demo, but the metrics and all of the logs can be seen after some time of actually requesting the service. So let me do it now. So is there anyone who would like to order coffee from our own coffee shop? No worries, it's late, I know. There's no caffeine, it's just a JSON coffee. OK, Okay, so I see an open hand. Can I get your name? Maya? Maria. Okay. Is it like this? Okay. And which coffee would you like? Americano. Okay. So I will prepare it myself. I'll send it, and as you can see, all of it has been done successfully. So I'll create 3 more. Then I'll try to, for example, create, so let me employ Honza and make coffee for me. And I'm only drinking batch brew. Oh, okay. Honza sense point is broken. We'll have to see it in logs, what happened. So let's, for example, Marek, he's not here, unfortunately, but he'll make coffee for me nevertheless. Takes a bit more time, but it should be okay. But so let me order more of those. Okay, so we'll see the results after me actually showing you how it's all implemented. I'll try to be as fast as possible since I think the pizza is arriving. Okay, so logging. Very simply, only thing you need is just initialize the logger. This differ refers to sometimes the logs can be buffered, and the sync just what it does is to empty the buffer before everything ends or the app is closed. And the usage, very simple. Each of these zap string calls will end up as JSON fields. So the result is going to be this JSON with these fields and these values. Metrics, yeah. So we'll create a session, AWS session, and then from the session we can get the CloudWatch instance, and I've decided to wrap it inside of my own CloudWatch metric structure and have logger and tracer available for me as well. And then this is the usage of metrics. As you can see, you will create a metric structure or a slice of it, and you will use a metric name, which will be shown in AWS, the value, unit, dimensions. These are used for filtering in the metrics. So for example, if I would put, for example, HTTP route here as a dimension, you could see request duration for different HTTP routes and as timestamp. Yeah, and you will just call CloudWatch client instance and the method put metric data, and you're just good to go. Yeah, and tracing here, the code wouldn't fit. So let me show you from my IDE. Is it visible for you guys? Okay, great. So tracing initialization. So firstly, you have to create a resource, which is like a structure that holds metadata for the whole tracer. Then you need to create an exporter, which is responsible for exporting the telemetry data through HTTP to the collector, which we have seen in the infrastructure diagram. And the collector actually collects the data from our service and then imports it into the CloudWatch X-Ray, it's called, the service that is responsible for tracing. So yeah, that's how we achieve open telemetry data transfer and conversion into AWS X-Ray. Then we'll register tracer provider, which helps us having the tracer available through the whole application. It's like a global thing now. We have to also use the text map propagator, which serializes and deserializes the tracing data from and to context, which all of the tracing data is actually saved in context, which is propagated throughout the whole app, as you guys are probably used to in Go. And basically that's it. There's a shutdown of the trace provider, and basically that's it. And here we will just get the tracer instance, and then how it's used. So let me show you. For example, I have created a middleware which is run on every request, and as you can see, I'll get the first context, because normally when you are using tracing and creating spans, which are the smallest, let's say, intervals that describe one operation, usually you have the data already saved in the context, but as this is the first trace that we are, or span that we are making, we need to get the initial data from headers. So that, for example, if you want to achieve distributed tracing, you will use trace ID coming from, for example, a component that is calling your service, for example, API gateway or a different microservice, for example. Okay. Yeah. So here we will start the tracer, start the span, and in differ we'll end the span. We can definitely add attributes to the span, so that in the final view we'll be able to see some metadata, and based on the status code of the request that we are calling, we can set a span to either error or OK, which will result in a nice view, but in the trace. Okay, so let me move to the demo. It's here. Is it visible? Oh, okay, hopefully. So this is the dashboard I was talking about. We have different metrics. Let me try it. Okay. So we have different metrics. This is the request count. This is the response time. As we can see, some of the requests were taking a bit longer. Then we have the usage. You can see also that memory utilization was spiking for some reason. And this is our own custom metric, which counts how many coffees were created. As I was saying, there was an alarm, right? And since I've created around 13 coffees, the alarm should be telling us there's something wrong, and indeed it was. This alarm is actually, we have in this place, which was the time I was creating these coffees. No, this time we got through the threshold, and Actually, I think I should have gotten an alarm in my email. Okay. About the logs, I think we can be very fast with this. As you can see, structured logs. We can use this smart filtering to, for example, filter those logs that ended up in error. No one, okay. Okay, there are a few errors actually here. Yeah, some errors. Okay, so let me quickly demonstrate the tracing part, which is probably the most important. So I'm curious why Marek is making the coffee for so long. I'll request it again. And in headers, as you can see, we are also passing in response the trace ID. I can use that and try to find the trace, which is right here. Trace, oh, we got it. And as we can see, this represents how long the whole request took. And then there's something happening, weird happening, because the actual database query only took like 3 milliseconds, and there's unexplained behavior here. So let me show you the code, and okay, let me Marek's handler. As we can see, he allocated 250 megabytes of memory, and he slept for one second. So that's why. And until here, we get to the actual database query. So voila, the traces helped us debug that. And last example, let me call Matush, and hopefully he can make me a cappuccino, right? Probably spelled wrong. Damn. He's always making this. It's this guy. When I never ask him for coffee, I'll always bring Borovichka. It's yeah. And let me get back to my presentation. So what have we learned? How to set up basic observability in Go. Structured logging with Zaplogger, metrics and alerts with AWS SDK, and tracing with OpenTelemetry, the collector, and AWS X-Ray. And last but not least, never ask Matush for coffee. This is basically his nickname and how he's remembered in or saved in Slack, company Slack. Yeah. Materials. Hopefully, we can somehow share the presentation, and you can see the whole code of the whole app with the infrastructure CDK as well, and open questions.